So we have the implicitly defined equations, square root of x plus square root of y equals 4. We know that y of 1 equals 9. And we are asked to find y prime of, not 4, but y prime of 1. And we could even find the tangent line at that point, but we're going to find the slope of the tangent line when x equals 1. So, or at the point 1, 9. So, one thing we might do first is write these both as power functions, x to the 1/2 plus y to the 1/2 equals 4. And now we do our implicit differentiation. So our x comes out pretty much like normal. We pull the 1/2 down in front, decrease the power by 1. Our y is our implicitly defined function, is our implicitly defined piece, so the 1/2 still comes out front. Leave the y alone, goes to the negative 1/2, and we have to multiply by dy dx or y prime, whichever notation you prefer. And now here's the part that often gets forgotten. The derivative of a constant is 0. So it would actually not be too difficult to solve for y prime. We could move this term over to the other side. So we'll have this negative 1/2 x to the minus 1/2. So those will cancel. We could divide both sides by 1/2. So this will stay negative over here. And then we'll divide by this guy. So we get y prime equals x to the minus 1/2 over y to the minus 1/2. Or because both of those exponents are negative, we could write it as y to the 1/2 over x to the 1/2. Or take it one step further, square root of y over square root of x. Or you could do the square root of y over x if you'd like. Any of those would be fine. Let's leave it right here. We wanted y prime of 1. And we know that when y is 1, y prime 1, so we would know that when x equals 1, y equals 9. That's the point it needs to go through. So we have square root of 9 over square root of 1. So that's where we get those values from. So 3 over 1, or 3, is the slope of our tangent line. And then if we needed to make the tangent line, we'd have our slope and our point, and we could create our tangent line.